Lesson 27 now for something completely different. So what we're going to do is we're going to basically play with some fractions. Now we've done things like reduce fractions before, but look at that thing. What are you supposed to do when your fraction has teeth? Like this one has teeth. It has x squareds in it. Well, let me show you the first thing that you should not do. And you know what? I'm going to write this as a warning in red because it's actually that important. Warning. And we just saw this in the previous lecture, by the way, which is good because we can just bring this back to memory. Remember the old all or nothing rule of canceling. If you made it through the entire last video, then you saw this and you know what it means. If you don't know what it means, let me remind you what it means. It means, no, I can't cancel this 4. No, I can't cancel all of the 4s. No. And why can I not cancel the 4? Well, the short way to say it is because it's all or nothing. You can't cancel a 4 there. You can't cancel a 4 there. So you can't cancel a 4 anywhere. All of a sudden I'm thinking of Dr. Seuss for some reason. I don't know why. Anyway, can't cancel here, can't cancel there, can't cancel anywhere. That's Dr. Seussy, right? Anyway, we cannot cancel those 4s. What you got to do is you got to first, when you've got these teethy fractions, first factor it up. So we're going to have to remember all of our factoring, which is what we were doing before we got into those radicals, before we got into lines, in fact. So, we've seen factoring before. Hopefully you've got some good notes. Maybe you've got a summary of you do your differences of squares this way, you do your trinomials this way, you do your, well, we're not going to factor by grouping in this set, but pulling out common factors, those are the basic things we have to be able to do. So we're going to get a little bit of reinforcement of that as we learn to unstack rational expressions. So let's see, getting back to this thing. This, by the way, is called a rational expression. Rational means ratio, means fraction. Expression means it's got x in it usually. So it's an expression, which is a fraction. And anyway, we're trying to reduce it. It's like reducing fractions. Factor it up. So hopefully you're recognizing a diff of squares. Remember that pattern? So on the top, we've got one of these difference of squares things. And remember how a difference of squares factors. You got something squared, you got something else squared. Well, minus them, plus them, just like this. So what we've got is an x squared minus a 2 squared, really. That's how you get a 4, is a 2 squared. And so the a and the b are really an x and a 2. And so I put an x and a 2 here, an x and a 2 here. And what I'm going to get is I'm going to get x minus 2 times x plus 2. By the way, some people write this the opposite way. They write x plus 2 first and then x minus 2. It does not matter at all because it's multiplying, you can multiply in any order. Anyway, that's the top. So we factored the top. Now we got to factor the bottom. Maybe a different color here. Now what is this thing? Well, that is a trinomial. This is the kind of thing that you have to try to unfoil. You say, oh, it's got 3 terms. I'm going to try to figure out what we foiled to get that. And remember the idea that the x squared has to break up into the 2 first positions. And the good news is there's only one way to do it. It must be x times x. That's cool. The 4 has to break up into the last 2 positions. Now it might be a 1 times 4 and it might be a 2 times 2. You've got 2 guesses. So you just make a guess and you hope you can get it to work. The thing you need, recall, is for the outer product and the inner product to add up to your negative 4x in the middle. That's what you need. So the outer product right now is a 2x. The inner product right now is a 2x. Now if I'm trying to add up to a negative 4x, I will want these both to be negative. And if I want those to be negative, to make this a negative 2x, I would have to multiply that. I would have to multiply a negative 2 times an x, right? So that has to be negative, and same thing over here. And so that's the bottom. So let's put this all back together then. Yeah, let's do that. Let's do that over here someplace. Okay, so what we've got then is we've got the top is an x minus a 2 times an x plus a 2. The bottom is an x minus a 2 times an x minus a 2. Now we can try factoring. Now you have to recognize that these are called factors. This times this. I've only got two things there. I've got an x minus 2 and actually I've got another x minus 2. That counts as two factors. And then on the top I've got two factors. I've got an x minus 2 times an x plus 2. It might look like we got 4, 8, 16 things here, but we don't. And I just think of these as bubbles. So these two bubbles are the same. That means we can cancel them. X minus 2 goes into itself once, leaving us with an x plus 2 on the top, an x minus 2 on the bottom, and we are done. Again, you cannot cancel those x's because if you can't cancel an x everywhere, you don't cancel an x anywhere. Same thing goes for the 2's. We cannot cancel those 2's because there's a 2 here and here, but not here and here. If you can't cancel everywhere in a fraction like this, you don't cancel anywhere. So that's it. So that's the basic process for simplifying fractions that have all these x's in them. Again, the official word for this is a rational expression. Fractions with x is called a rational expression. These are polynomials, right? Okay. Now, we got to do this one. This would be a good time for you to try to remember all this factoring stuff yourself. See if you can remember it yourself. Pause, in other words, and try this yourself. Unpause. Okay, well, the easy thing is the bottom. If you recognize a difference of squares, then you can say, oh, okay, that's one of those 2x minus 3, 2x plus 3 deals, because this is 2x that's being squared, and this is 3 that's being squared. So you take the 2x, put it here and here, you take the 3, you put it here and here, you minus them, you plus them, you're done. Okay, that's we've done this before, right? So I'm just trying to bring it back to your memory here. So that's what the bottom is. Nice difference of squares. The top, well, you get that unfoiling thing again. I know nobody really likes unfoiling, but here's a remark. Hey, that's an interesting word to use in a math lecture. Remark. Always keep an eye out for common factors. You see the 4, the 2, the 6? They have 2's in them, right? Always keep an eye out for common factors. Now, when I say common, again, I'm talking about common to all three terms. You wouldn't want to say, oh, there's an x here and an x here, so let's pull an x out, because that one doesn't have an x. So you wouldn't want to pull out an x. But all of these terms do have 2's in them, so I will pull out a 2. 2 times. And that would leave me with the 2x squared minus an x minus a 3. Okay. Now, let's go back to blue ink. To finish this up on top, I have 2, and then I'm going to have to unfoil that sucker. 2x squared is 2x times x. That's the good news. There's only so many things you have to guess. 3 is either 1 times 3 or 3 times 1, right? So there's only 2 things to guess. So hopefully you quickly came across this combination as working splendiferously. Notice that I have 2x times x is 2x squared. That part works. Outers and inners, that's the rub. 2x times 1 is 2x minus 3x. That does give me a minus x. See, it works. It works. Still trying to work. Okay. And then lastly, the minus 3 times the 1 would give me the minus 3 at the end. So it works. It works. Okay. So now I'm looking at this thing, and I'm trying to see what will cancel. You can cancel bubbles. Let's try to make it clear that that's a parentheses. Notice I can cancel these two bubbles. The 2x minus 3's can cancel out. And I guess that's all that's going to cancel out. There's nothing else that cancels, right? This 2 doesn't cancel with anything on the bottom, again, because it's all or nothing. And that's it. So that's your answer, actually. 2 times an x plus 1, that's your numerator, and then a 2x plus 3. You can put that in parentheses if you want. It's kind of optional, because by default, if you're at the bottom of a fraction, it's understood that you're grouped like this. So whether you put them there or not, it's up to you. Okay, so hopefully you're starting to remember how this factoring stuff was going. This is what you have to do to reduce fractions like this, and especially, please remember the all or nothing rule. Do not just cancel x's and stuff. You don't cancel if you can't cancel. If you can't cancel everywhere, don't cancel nowhere. Factor instead, and then you can get rid of bubbles and stuff like that. That's the way you tackle these things. Okay, so that's like a topic into itself. Now that sets us up a little bit, but I have to do something else to help set us up for the main event, which is unstacking is going to be the main event. What do I mean by unstacking? Well, here's an example of what I call a stacked fraction. That sucker's too tall. Okay, we don't want our fractions to have 4 layers to them. You want it to be like a nice 2-layer thing. I was going to say a hamburger, but I guess that's 3 layers, right? What has 2 layers? I don't know, but you want 2 layers. Pardon me, you want your fractions to look like fractions. So what the heck are you supposed to do with this? Well, the rule is, might as well state the rule first. The rule is that you take the top and you divide it by the bottom. Now, I claim that you know that rule, even if you don't know that you know that rule, because I'm going to erase this in a second, so you don't write this down. But example, if you had something like a, I don't know, let's put an 8 over a 16. Or no, let's not do it that way. Let's do it this way. Let's do 16 over 8. You know how to reduce that, right? 16 over 8 is equal to 2, right? The 8 cancels into 16 twice. But notice you can think of that as the 16 is being divided by the 8 to give you a 2. That's what a fraction means. It means the top divided by the bottom, just like I'm saying there. If you think about it, that's what the symbol for division is. It's a fraction bar. With like saying there's something on top, something on bottom, divide it. Okay, so unstacking a fraction, the whole secret is right there. It's take what's on top and divide it by what's on the bottom. That's what you do. So what's that look like for this one? Well, the top is a 3/4, and I'm going to divide that by the 1/3. So I turned it into like a normal looking math problem, I guess. Now remember that when you divide by a fraction, what you really do is you multiply by the reciprocal, right? You change it into multiplying by the reciprocal. And then you can multiply straight across. 3 times 3 is 9, 4 times 1 is 4, and you're done. So that looks a lot better, right? Doesn't that look a lot better than that? Yeah. Please do not leave your fractions all stacked up like that. You can take them apart. You can break them down, or you can shorten them, or whatever the word is. Trim them. I don't know what we're doing. We're making them look better. Now the important thing is knowing when you're going to do this unstacking, you have to be able to tell where's the top and where's the bottom, right? That's important because you're going to take what's on top, divide by what's on the bottom. So when you're looking at this fraction, you got to make sure that it's clear what's the top and what's the bottom. And I think we can tell that this fraction bar is just a little bit longer. So this is like the top and this is like the bottom, right? So top divided by bottom is going to look like this. Take what's on top and divide it by what's on the bottom. 1/2 divided by 3. Now, the rule, quote unquote, when you're dividing by a number, you're multiplying by the reciprocal. Notice I'm only taking the reciprocal of this. Leave the 1/2 alone. You don't flip that over. You just flip the 3 over and then make it multiplication. So 1/2 times 1/3, and then you multiply straight across on the top, you multiply straight across on the bottom, and you get a 1/6. Let me show you how this, let me prove to you that that has to be 1/6. What's a 1/2? Well, here's half a pizza, right? If I take the half a pizza and I divide it by 3, which means divide it into 3 pieces, isn't it going to look like this? And don't those look like 1/6 of a pizza? Sure. I love pictures like that. They make me happy. So anyway, that's the idea. Top divide by bottom. Couple more just to make sure we get this. Top divide by bottom. Make sure you can tell what's the top and what's the bottom. That's the important part, of course. That's extremely important. So here it's a 1 on top, and we're dividing by a 2/3 on the bottom. So again, to divide, you take the first number, don't do anything with it, although I put it over 1 because I wanted it to look like a fraction. I know that I'm playing with fractions, so I like to make whole numbers look like fractions by sticking a 1 underneath, which is always a free move. So to divide by 2/3 is to actually multiply by the reciprocal. And then actually it's just 1 times 3 is 3, 1 times 2 is 2. That's all it is 3/2. And one more. I throw this one in because it's worth knowing. If you have mixed numbers like this, to use the rules, the usual rules of fractions, you should make them improper first. Whether you're adding, subtracting, multiplying, dividing especially, it's just really a good idea, especially multiplying and dividing. Make them improper first. So remember how that little swing moves? 2 times 2 is 1. Excuse me. 2 times 2 is 4 plus 1 is 5. So this ends up being 5/2 on the top. And then the bottom, 3 times 3 is 9 plus 1 is 10. So this ends up being a 10/3 on the bottom. Okay, make them improper first. Top, divide by bottom, which means top times reciprocal of bottom. So you flip the bottom over like that. And then, oops, you could multiply straight across, but remember, when it comes to multiplying, we're allowed to do this cross-cancel stuff, right? I can say 5 goes into 10 twice. That's only legal for multiplying. Maybe I'll write that down. Cross-cancel. Legal for multiplication only. But if you can do it, it's a nice idea because now you've got 1 times 3 is just a 3. 2 times 2 is just a 4. 3/4. That's what you get there. So who'd have thunk it? 2.5 divided by 3 1/3 is 3/4. Okay, so those are the first 2 points that or the first 2 things I had to get across before we get to the main event. So what were the 2 things? It was how to reduce fractions that have teeth. You have to factor first, then cancel things. If your fraction's too tall, you're gonna, top divide by bottom thing. Okay, now we get to the main event. This is where the money is. So look at those things. Whoa, that's big looking. It's not so bad as it looks, really. What we want to do is we want to simplify these tall polynomial fractions. They're tall and they're polynomial. They're tall and they got teeth. So first, I'm going to say that it's 2x plus 4 over 3 is being divided by. Okay, this is what we were just doing. You take a stacked up fraction, you break it into a division problem, or you recast it as a division problem. So what's on top gets divided by what's on the bottom. Maybe I'll write that down again. Top is being divided by the bottom. Now, in order to do that, you actually multiply by the reciprocal, right? So far, so good. Now comes the part where we want to factor things. Now, there's not a lot of factoring to do in this problem. The x plus 2, what are you going to do? Nothing, it's done. The 6, it's a number, you're done. But the 2x plus 4, remember you can pull out a common factor of 2, like this. So that first fraction, we're going to change it just a little bit. 2 times the x plus 2 over 3. This is going to be 6 over x plus 2. And like I was saying earlier, when it's part of a fraction like this, the whole bottom is understood to be grouped. So you could put the parentheses there just to emphasize it. But that's kind of like the default thing here. It is grouped. It's multiplication. What do you say we look at cross-canceling, right? That's legal when multiplying. The x plus 2 bubbles will cancel. Awesome city. And now look at the 3 and the 6. 3 goes into 3 once. 3 goes into 6 twice. That's happy canceling is what that is. Multiply straight across the top. 2 times 1 times 2 is 4. And on the bottom, 1 times 1 is 1. And 4 over 1 is really just 4. Cool, eh? So that's how you play this game. You know, maybe I'll take, do I dare? Do I dare? What the heck is going on here? Yeah, I dare. I'm going to dare right now. I'm going to dare. So allow me to do this one. Allow me to skip this step and say what's on top. Okay, divide by this, right? But we know that that means multiply by its reciprocal. So why don't we just cut to the chase and flip it over right now. Okay, that's not a bad shortcut, right? It saves you about this much writing, which isn't bad. It saves you that much space. That's probably the important issue. So I guess my new rule is top times recip of bottom. That'll be an easy rule to remember. If you can remember this, it's top divided by bottom, then you can say, oh, divide by the bottom means multiply by the reciprocal. So it's just the same rule stated two different ways, really. Okay, so we got that part figured out. Now comes the factoring part. You look at the x squared minus 4, and you hopefully recognize a difference of two squares. So you say, oh, that's going to be one of these x minus 2, x plus 2's. Cool. Looking at the bottom here, what can you do with a 3x plus 9? You can pull a 3 out if nothing else. Remember, that's always the first thing you should try anyway, is can I pull something out? If so, do it. Now we come over to this other fraction. Look at the top. Can I pull something out? I sure can. I can pull out a 5, which will leave me an x minus 3. And then you look at the bottom here, and you say, can I pull something out? Yeah, I can. I can pull out a, I can pull out a 5. I really can. And that'll leave me with an x minus 2. Okay, so we unstacked it. We've got it all factored up into its little pieces. Now comes the fun part, the canceling. That's the part I like. X minus 2's are going to cancel. Woohoo! 5's are going to cancel. Woo! And I guess that's it, really. Because that's an x plus 3, that's an x minus 3. Those aren't the same. Those can't cancel. Well, usually you get more canceling and it's more fun. So what we got here is we got the x plus 2 on the top here, multiplying the x minus 3 on the top here, and you don't actually have to multiply it out. Factored form is a wonderful form, really. Okay, and then what do we got on the bottom left here? We got the 3, and then we got the x plus 3, and that's really all we got. And that's it. Nothing else cancels, nothing else to do. You don't have to re-multiply it out. It looks great that way. That looks fabulous. Factored form is a fabulous form. Okay, having fun, right? Oh, we just got a couple more to do. It's just good practice. It's kind of like, you know, doing a couple more chin-ups at the gym or whatever, lifting weights a few more times, lifting whatever, jumping on the ball a couple more times. This is the exercise part of it. So I'll tell you what, let me do this one myself, and then I'll invite you to do that one as a try it. So the first thing I want to do is I want to do the old top divided by bottom, which really means top times the reciprocal of the bottom, right? To divide by this is to multiply by its reciprocal. So the top is this x squared minus a 5x plus a 4 all over a 4. And we're dividing by this, which means we're multiplying by the flip it over. Multiply by the flip it over. Okay, cool. So I unstacked it. You might say step 1 is to unstack. Step 2 is going to be now factor. That's a lousy place to write it. I'm going to write it over here. Now factor it up. Factor all these parts. So usually the hard part's the trinomials, right? Because you have to do a little guessing. So let's get this one out of the way. Well, actually, x squared has to be x times x. So that's actually pretty good. Now I need two numbers that multiply to 4, and they're going to give me a 5. Well, I think that has to be a 4 times a 1. And we're adding up to -5, so it has to look like that, right? You've got a negative 4x here. You've got a negative 1x here. That gives me the negative 5x. And then you got a negative 4 times a negative 1 gives me the positive 4, so that works too. So there's that. The 4, hey, I don't have to do nothing. Over here, looking at a 4x minus 16. Well, it's not a difference of squares or anything. X isn't squared, but you can always try to pull something out. And in this case, pulling out a 4 is just the thing. Pull a 4 out, and you're left with x minus 4 like this. Then, on the bottom, what is that? That's a difference of squares, yeah. That's a difference of squares. So you take the x minus the 1 and the x plus the 1, like that. Cool beans. Now, canceling time. Cancel the 4s, they're gone. Yeah, you could put 1s here if you want. The x minus 1s are going to cancel, right? Now these do not cancel because they're both on top. So they can't cancel. You have to have one on the top, one on the bottom. So what we got then is we've got an x minus 4 on the top times a 1 times a 1 times another x minus 4 on the top. And on the bottom, we got 1 times, and then we've got an x plus 1 on the bottom. Or if you prefer, that form is fine. But if you got x minus 4 times itself, often what we'll do is we'll just say, yeah, it's x minus 4 quantity squared. Nifty nice, nifty nice. Yeah, like I say, this would be good for you to try this one right now. Try it. It's not as bad as it looks, I promise. Well, once you get past the trinomial, it's not bad. All right, let's get her done. So it's going to be top times reciprocal of the bottom. So I'll call this step 1 unstack. So I take what's on top, which is this fraction here. I get this fraction here, right? That's a big fraction. And I divide it by the bottom, which means multiply by the reciprocal. So I had to flip that over, right? You're dividing by the bottom, which means you're multiplying by its reciprocal. Okay, cool. Factoring time. Well, before we get too far unfoiling this, notice these are all even numbers, 12, 10, and 8. That's always what you want to do first, I promise. If you can pull something out, even if it's a 2, pull it out. So I pull a 2 out, leaving me with a 6x squared minus a 5x minus a 4. Okay. Before I get to the rest of this stuff over here, why don't we just finish factoring this thing up? It's going to have a 2. Now that's a trinomial, which means we guess that it came from foiling something. 6x squared, well, it might be 3x times 2x, and if I can't get that to work, I might have to try 6x times 1x. I don't know. I'm guessing it's going to be 3x times 2. Let's see if I'm guessing right. Now I have to break up the 4 somehow. So that's either 1 times 4 or 2 times 2. So you get a couple things to play with here. I'm going to guess something like this and see if it works. Because that gives me a, well, that's a 6x squared, right? So that'll give me that term. So that part's fine. Now it's the outers and inners that really matter. Notice that's going to give me an 8x for an inner product, and then that's going to give me a 3x for an outer product. And I'm trying to get the inners and the outers to combine and give me a negative 5x. Well, I know how to do that. You make that a negative and that a positive, and then they'll combine to negative 5x. So that means this has to be a negative 4, and this has to be a positive 1. That way, when I multiply negative 4 times 2, I get a negative 8x, and 3x times positive 1 would be positive 3x. So let me get this stuff out of the way now, because that's how it factored. So the advantage of electronics is I can erase stuff. Okay, so that's That's the top, right? It becomes this. Let's try to make a little division line there. The bottom, looking at the bottom here. You getting good at recognizing these differences of squares yet? 3x times 3x will give you 9x squared. 4 times 4 will give you 16. So you minus them, you plus them. So that's how you factor that part. The 1, well, you don't factor the 1. It's just a 1. That's all there is, and there ain't no more. This part we can factor a little bit because I smell 4s. So you take a 4 out, leaving you with a 2x plus 1. Cool. And now comes the canceling time. So I've got this big, that's not there anymore, right? We're done with that. We've got this big multiplication that we're looking at. And we're trying to cancel stuff at the moment. And I can cancel the 2x plus 1s right away. Boom, boom. And what else can I do? Oh, I can cancel these 3x minus 4s right away. Boom, boom. And what else can I do? I can cancel this 2 into this 4 twice. Boom, boom. And you got to keep track of what's left here. What's left on the bottom is I got a 3x plus 4 times a 1 times a 1 times a 2. So I'll call that a 2 times a 3x plus 4. Now remember, that's on the bottom, so make sure you put it on the bottom. On the top, I got basically a 1 times a 1 times a 1 times a 1. That's a 1. Now the biggest mistake I usually see with this problem is a lot of times people forget the 1 on top. So don't forget the 1 on top, right? You have an upper zone and a lower zone. The 2 and the 3x plus 4 belong in the lower zone. You've got a 1 in the upper zone, so to speak. So, okay, cool. I think that's the whole lecture, ain't it? Yeah, there's the complete dot. So, yeah. Anyway, cool. I hope you're sort of enjoying this. This is a really good workout. This is very good to start getting in the mood for some kind of like college algebra course or intense algebra course, because you're really playing with x's now, folks.